Okay, so we're going to go over how to determine what the limiting reactant is mathematically. We explained it yesterday, kind of, in general terms, and I had a lot of numbers that I put up there. But today I'm going to show you how I got some of these numbers. So let's go ahead and start off with the hamburger analogy that we used yesterday. Yesterday we said that we had one, in order to make a hamburger, it takes one patty and two buns to make one hamburger. So let's say you had 12 patties and 18 buns. Which is the limiting reactant? Some of you may already be able to see it now, but I want to show you how this works mathematically also, so that you can then go ahead and figure out, when the numbers aren't as easy to see. Some of you guys won't see it yet, some of you guys will. But when the numbers aren't so easy to see, how you could calculate it out so you can determine which one is going to be the limiting reactant. So we got to figure out how many hamburgers 12 patties can make. We got to figure out how many hamburgers 18 buns can make. And whichever one gives you the least number of hamburgers, that's the limiting reactant, because at that point, that's when that thing will run out. That item will run out. And we're going to do the same thing with reactants in a chemical reaction. So let's go ahead and show how we do this. First thing you do is, in this one, we have 12 patties and 18 buns. So what we're going to do is we're going to write down 12 patties, and we're going to write 18 buns. And what I'm going to do, I do it a little differently than Tyler DeWitt does. I kind of like my way because it just compares the same thing. His works. You have to think a little more. This one just kind of, whichever one has the smallest number, smallest answer is the one that's the limiting reactant. So what I'm going to do is I'm going to convert the 12 patties into hamburgers. How many hamburgers would I get from 12 patties? Right? And so I just use the coefficients, right? I want the patties to cancel out. So just like you would with mole-mole relationships, I'm going to put patties on the bottom and hamburgers on top. And the coefficients for each I'm going to put right here. So there's one hamburger, and the coefficient for hamburger is 1. Coefficient for patty is 1 also. So I'll put that there, right? So basically what I'm going to do is, in order to figure out how many hamburgers I get from 12 patties, take 12, multiply by 1, divide by 1. It's going to give me 12 again, right? So 12, and my patties cancel, leaving me with hamburgers. So from 12 patties, you're going to get 12 hamburgers. Okay, that's not the maximum number of hamburgers you can get from 12 patties. Let's do the same thing for the 18 buns. So we're going to do the same thing, except this time, well, let's see. For every one patty, it takes 2 buns. Oops, sorry. I did that upside down. Oh, yeah, no, I want hamburgers. Okay. Well, too much. All right. So I want buns to cancel out. This is why I do the bottom first. Coefficient for buns is 2. And I want hamburgers. So in both cases, I'm going to want hamburgers because I'm going to want to figure out hamburgers. How many hamburgers I can make from each of these. So there's going to be 1 hamburger. So 18 times 1 is 18 divided by 2. That's 9. 9 buns cancel, leaving me with hamburgers. Okay, so what this is telling me here is that from 12 patties, I get 12 hamburgers. From 18 buns, I only get 9 hamburgers. So this is the one, this number is smaller than this one. Therefore, the 18 buns here, 18 buns is the limiting reactant. It's what limits. It's only going to, the 18 buns are going to run out after 9 hamburgers. So even though we have enough patties for 12 hamburgers, we are going to run out of buns after 9. So that'll be it. Okay. So we will only use 9 enough patties for 9 hamburgers, which would be 9 patties. From there, you can go ahead and figure out, well, how many patties do we need? We don't need, oops, sorry. From 9 hamburgers, how many patties would we need? And from there, you can figure out how many patties are left over. Okay? That's the main idea. Now let's deal with some chemicals. All right, so I have this reaction. And the first one I'm doing is a 1-to-1 ratio. Because it's nice and simple. You can probably see it. Basically, the idea, though, is calcium plus iron 2 oxide goes to form calcium oxide and iron. Okay, we got 1.25 moles of calcium, 2.35 moles of iron oxide. When it's 1-to-1, it's pretty easy, whichever one is the smallest number. But still, you can do the same thing, in case you don't know. Just pick one of these, whichever one you'd want to figure out. Let's go ahead and use iron. How much iron can we make? So what I'm going to do is I'm going to start off with calcium. I'm going to write down my 1.25 moles of calcium. This would work, by the way, if we try to convert it to calcium oxide also. Either of the products will work in this case. I'm going to write down both my reactants. So 2.35 moles of FeO. So this is how many, that should be 1.25. I don't know how I got 1.55. Let me fix that. 1.25. And let's go ahead and convert the moles of calcium to moles of iron. And these are all balanced, right? This is already a balanced chemical equation. Everybody has coefficients of 1, so it's real simple here. 1 mole of calcium goes on the bottom because I want to get rid of it, and I want to turn it into moles of iron. Okay. Why? Because we chose it. Okay. Sometimes the questions will ask, how much iron? So you'd use iron. Or how much calcium oxide is formed? Then you use calcium oxide. Why use iron when you're being asked about calcium oxide, right? But in this case, we just want to know which is the limiting reactant. So we're going to turn our 1.25 moles of calcium cancel. And since we're multiplying by ones, we're going to end up with 1.25 moles of iron. We're going to do the same thing for the iron oxide. 2.35 moles of iron oxide. How many moles of iron would that create if all of that reacted? And so once again, we go ahead and put moles of FeO on the bottom because we want to cancel it out. Moles of Fe on top. Don't get confused just because they both have Fe in them. They're different substances. Right? So coefficients of each of these is 1. So 2.35 times 1 divided by 1 is 2.35. Moles of FeO cancel, leaving me with moles of Fe. So what this is saying here is that my 1.25 moles of calcium can make me up to 1.25 moles of iron. My 2.35 moles of FeO can make me 2.35 moles of Fe. So we would run out of calcium by the time we got to 1.25 moles. And after that, we can't make any more. We can make more Fe from the amount of FeO here. And remember, it really depends on how much the amount is. We could have switched them. And if you switch the quantities, then it would be the opposite result. So since this one is smaller than this one, this will be our limiting reactant. The calcium here will be our limiting reactant. And it was pretty easy to see, but just wanted to show you guys calculationally how you do it. And so we would say that this is our limiting reactant. Oops, running out of space there. Not the best place to put it. But that's basically what you do, right? You put down your moles. You can do molecules also. You can do moles. You cannot do grams. Don't forget. No grams do not work on this because we have to turn them into moles. So you put the moles of both reactants, turn them into moles of the same product, right? How many moles of this product can you get from this amount of this reactant? And how many moles of the same product can you get from the second reactant? Whichever one gives you less, that's the one that's limiting. And then you can use this to try to figure out, if you want to figure out how much moles of FeO are in excess, you can try to figure out from 1.25 moles of FeO, how many moles of FeO will react along with it. Right, and that should, if I did the calculations, I'll find out that's 1.25 moles. And so then you subtract the amount reacted from the amount you actually start off with, and that'll tell you how much is left over in excess. So whenever you ask for excess, you got to figure out the substance here in excess. Not all these will react, only a certain amount. The amount that you're limited by. And so either you can use this to calculate the amount of FeO, or you can use this to calculate the amount of FeO. In this case, they're all the same. They will give you that 1.25 moles of FeO reacted. So how much is left over? Well, 2.35 minus 1.25 looks to be like 1.10. Excess FeO3, FeO is equal to 2.35, that's how much we had, minus 1.25, that's how much reacted. And so it's going to be 1.10 moles. Okay, so that's how you do that. Now let's do one that's a little more involved, one that has some more coefficients. All right, so this reaction right here, H2 plus S8 goes to form H2S. And because there's S8, and it turns out that it turns into H2S, we need to balance this equation. So this equation is balanced. There's 8 S's, so you need 8 in front of the H2S because there's only one S here. That balances out the sulfurs. But that puts 16 hydrogens on the right side. They come in pairs, so we need 8 pairs. Okay. So looks like you're going to need 8 times more hydrogen moles than sulfur, S8 moles. So we have 3 moles and we have 0.35 moles. Easy way to do it, just do it like we did before. All right, so I'm going to put down here 3.0. We have 3.0 moles of H2. We have 0.35 moles of S8. You might go, oh, look, there's so many more moles of H2 than S8. S8 is probably the limiting reactant. Maybe, but we have to check on it because we need 8 times as much. So once again, take your moles of your first reactant, convert them into moles of your product. In this case, there's only one product, so we're going to turn it into moles of H2S. So we want moles of H2S to end up, and we're going to cancel out moles of H2. Coefficient the coefficient on H2 is an 8. Coefficient on H2S is also an 8. Is that right? Yeah, H2, yeah. Okay. Now over here, I'm going to take the 0.35 moles of S8. Okay. And we're going to go ahead and put moles of H2S on top, moles of S8 on the bottom, and the coefficient for S8 is 1. Coefficient for H2S is 8. All right. So let's see how many moles of each we're going to get. So this one's 3 times 8 divided by 8. Since they're both, whenever they're the same coefficient, they cancel out. Moles of H2 cancel out. We're going to be left with, we're going to make 3.0 moles of H2S. That's how many moles we get. Now, this one, 0.35 moles of S, we're going to take 0.35 times 8. So we're going to multiply it this time. 0.35 times 8 is going to give us 2.8. Divided by 1 is going to leave us with 2.8 moles of H2S. Once again, the moles of S8 cancel. Okay, so let me just go ahead and divide this. This is a little kind of close here, so I'm just going to divide that. That's two separate calculations. Now, if you look at this, 2.8 is smaller than 3.0. So therefore, we take the smaller number, which means that, yes, this is the limiting reactant. Okay, S8 is the limiting reactant. So all 0.35 moles of S8 are all gone. It's the one that runs out first. Okay. The 3 moles of H2S, I don't know. We want to find out, by the way, a lot of times the problem will ask you for grams, so all you have to do now is turn that from moles to grams. Right? You figure out the molar mass for H2S and multiply it, and that'll give you the grams of H2S. Okay. Now, if you want to figure out, this one's a little more involved. So if you want to figure out how many moles of H2S, how many moles of H2 are going to stick around? Well, let's find out how many moles of how many moles of H2 react. So what I'm going to do is I'm going to go ahead and take the moles of H2S that I know are going to be formed. We're going to form 2.8 moles of H2S. So how many moles of H2 are going to react along with that? Let me go ahead and move this up here. All right, so once again, I use my coefficients, mole of H2S, and this is the moles of H2. Now we're looking for moles of H2. We were given 3 moles of H2, but that's not how much reacted. H2 is around an excess. We want to see how much reacted. So 2.8 moles of H2S. If you look at the coefficients once again, H2's coefficient is 8. H2S's coefficient is also 8. It's not an accident. If one is 8, the other one might very well be 8 or whatever number, because that's where all the hydrogens are. So the hydrogens have to be balanced, which means that if you take 2.8 times 8 divided by 8, you're going to end up with 2.8 moles of H2. This is how many moles reacted, right? So this is how many moles of H2S we produced. And then we did this, went back to H2 to find out how much reacted. So we started off with our initial amount is 3.0 moles of H2. That's how much we had to begin with. Then we subtract 2.8 moles of H2 that reacted. And that leaves us with 0.2 moles of H2 in excess. Right. Question asks you for grams, then you can just go ahead and turn it into grams of H2. Okay, so that's how you can do a lot of the problems. Okay. Once again, basic setup is, let me do this in blue here. Step 1, write down, oops, let me get a pen here. All right, step 1, write your given amount of the first reactant. Step 2, write your given amount of the second reactant. Convert the grams, the moles of your first reactant into moles of one of the products. Do the same with the second for the same product. So you should have moles of the same substance twice, but they should be different numbers. This is how many moles you'd get from this amount of hydrogen. This is how many moles you'd get from this amount of S8. Whichever one is the smallest, that tells you that's your limiting reactant. And now you can identify S8 as your limiting reactant. This 0.35 moles of S8 are your limiting reactant. If you want to find out how much is in excess, well, you already know how much you started off with. Right? This is how much you start off with. This is how much you started off with. And so down here, you want to find out how many moles of H2 actually reacted. Okay. Not all of it reacted, once again, only some of it. How much? Well, we already know that this is the limiting the limiting amount. This is the amount of product you're going to make. And if you are asked for the grams, you can turn this to grams. But you use the moles of the smaller number of moles you get, and use that to turn it back into moles of the excess reactant. The reactant that was not the limiting reactant, the excess reactant, was H2. So we converted back into moles of H2. I know you got moles of H2 to begin with, but that's not the moles reactant. That's the moles you start off with, right? That's like having too many buns. You want to find out how many buns actually reacted once we ran out of patties, right? So you convert it into moles of H2. Oops. You convert it into moles of H2. That's how much reacted. Okay. That's different than how much you started off with. You take the amount you start off with, subtract the moles that reacted, and that gives you the moles in excess. Then from there, you can turn it into grams. At this point, once again, I'm assuming you can turn grams to moles by looking up the molar mass. Okay? All right, so hope that was helpful. If not, there's a couple other videos. Really, all the problems are basically this way.